This shouldn't take long. So today is October the 3rd. And we're going to continue to do long division. This will be over after this week, for the record. Okay, we're moving on. So long division with missing terms. So for our first math problem for our notes, we're going to take a quartic 4-term polynomial, 8x to the 4th minus 8x to the 3rd minus x plus 1. And we are going to divide him by a quadratic trinomial, 4x squared. So I know I've already kind of let the cat out of the bag, so to speak, but does anything catch your eye? What do you mean by that, Cale? You said that so bossy.
Oh, like just combine the like terms. Oh, we're both 3.
No. Boy, I thought you'd crack the code quickly. This hasn't happened to you yet, and I've made sure of this. I ran interference to make sure there's a missing term. And if you look at the dividend, that's the one that's first. It's missing its quadratic term, and that's going to be a problem. It might seem like, well, that's dumb, but it's a problem, and we can fix it really easy. So there's a term that's not there, and I'm going to point to the little void where it would be with an arrow. It's right there. There's a term. As we scaffold our way down, if you were to look back at all the 20 or so problems that you've done, every single one I've made sure perfectly scaffolds down by 1. Like 4, 3, 2, 1, 0. You can go back and look if you want. It's been that way every time. In today's problems, and there's not a lot of them, like 7 maybe, these ones will all have missing terms. And so when we write it in the right way, some of you picked up on like that I don't have it written correctly. The reason for that is because when we write it correctly, we're going to put in the missing terms. So let's begin. Let's start with our long division sign. And inside of there, I'm going to put my dividend, which is 8x to the 4th minus 8x to the 3rd, and then what? Right. I'm still in my dividend. I need to complete. How many x squareds are there in my dividend? Look at where the red arrow is pointing. How many x squareds do you see? 3. There are exactly 0 of them. If it's missing, then it's 0. And so we need to add a missing term right here. We need to add plus 0 x squared.
So that would just be x.
And lots of people that came before you would ask the question, like, that seems pretty dumb. Why should I have to do that? And then they are subsequently, they have it explained to them. Things go wrong if you don't fill it in, because there's going to be someone that's looking for a partner to subtract with. And if he's not there, then that someone says like, well, I guess, what do I do? And so long story short, you want to fill in all the gaps as you go. If your dividend has any missing terms, fill it in. If your divisor, the one on the outside, has missing terms, our second example will be one of those. We fill it in. Mm-hmm.
Will always be
Yeah, and honestly, it doesn't matter. That's a really good question, but plus 0 and minus 0 kind of have the same effect, but plus will probably be easier for us just to not get confused. Any questions so far? Okay, so I put that in red for you, and I'm going to go back now to writing in white, and I'm going to continue with my dividend, which is minus x and plus 1. Okay, so dividend complete. Focus on what I wrote in red. That's the important part of today. And then outside for my divisor, I'm going to have my 4x squared, my plus 2x, and my plus 1. And I'm going to go a little bit slow, just maybe for the few people that I polled today. Maybe I can say that one thing, that little nugget that kind of goes, that's what I was missing. Who knows? So here it goes. The process again is we look only at the term in the front and the term in the front. So don't do this on your own paper. It's terrible practice. I just do this to make a point. In case you're lost, all we do is say, what do you have to multiply the one on the outside by? to turn it into a dead carbon copy of the one on the inside? And the answer is 2x squared. So up top in our quotient line, we have to place a 2x squared. Because that thing that I just wrote multiplied by the first thing out front creates exactly the first thing inside. Not the opposite, exactly. And now what we do is we distribute what we just wrote on the top by what's in the blue parentheses. And as we do it, we're going to switch signs because that's what subtraction means to do. So what's the first answer going to be? Yep, so negative 8x to the fourth. It would have been 8x to the fourth. I'm switching it. Second one.
Negative 4x to the third.
And then this, hopefully you'll see now why we did what we did. I hope. If you don't, then I don't know what to tell you. The next one is going to be minus 2x squared. And you see now that without that red term that's above him, he would be out of place and he'd have no one to combine with. That's why we fill in the holes. Everyone should always have a partner for the addition and subtraction. So it's time to press on. So we do our thing, cancel these out. I heard Colby say negative 12 of these. And then how many x squareds? Minus 2 of those. And the next step is to drop the negative x and the problem starts over. So maybe I just helped someone's light come on. If not, let me show you again. The only thing now we have reset that you care about, and I'm going to scribble a lot of things out right now. I will undo all of this in just a second. The only thing that matters now is how many times do you have to multiply the one on the outside by to turn it into a dead carbon copy? Negative 3. You need to multiply it by negative 3x. You need to make it a dead copy. Don't think about signs and making opposites. All that will be taken care of when we switch the signs. So in order to turn the 4x squared into a copy of negative 12x squared, we must multiply by negative 3 extra x. And again, you see the blue parentheses on the outside. It's time to distribute. And as we distribute, we're going to switch the signs. And negative 3 hitting the first one would be negative 12x cubed. But we write plus 12x cubed. What's the second one going to be? Plus 6x squared. What's the third one going to be? Plus 3x. And yet again, cancel. How many x squareds do we get? Plus 2x. Next step.
Drop it down.
Drop it down. Kale loves that step, man. Drop it down. And I don't know if I should use my big fat blue marker again.
Yeah.
Oh.
Yeah.
Here, I'll switch. I'll switch to yellow. This time, all I'm trying to do is make what's on the outside multiply to make. That's it. I hope that you're seeing that. I mean, if I were a kid and I were lost, I'd look at that and go, oh, why didn't you just say that the first time? I got to make the one in the blue parentheses up there, multiply to make the one down below. Yeah.
Actually, never mind. Once you erase it, it'll make sense.
Nice. I agree with you, Colby. Good. So I need to multiply by 1 because I don't need to change it. So I'm going to put plus 1. What's up, Kale?
Okay, so what you're dividing by in the remainder?
It's just this.
Yeah, like gallon. On the bottom.
You're saying that this is a carbon copy of this?
Yeah. So isn't it just one you're done?
Yes.
Oh, no,
Kale's just making an observation. It's not like I'm not going to finish this problem. Kale, I'm on your wavelength and I agree with you. And yes, if you know what you're doing at this point, you could say I'm done.
So if they do like those two equals.
Yes, as long as they equal exactly each other.
Plus 1 up here and minus 1.
Kale. Kale, you and I were doing just fine until you started coming up with examples. Kale, if you get to the last step, Kale, look up here, please. And this is exactly the same as this. You're done.
Okay.
You do need to put your +1 to acknowledge that you're done. Got it? Okay.
Oh, I just realized that.
Good. Well, Kale, see, you helped Colby's light come on. That
I would
listen,
have done everything just exact.
right, and that's kind of the good approach here is just press on, and you'll make that observation when you're damn good and ready. Like when it comes, right? But in this case, I just look and I say I have to multiply 4x squared by 1. And then as you multiply it through, you put your -4 of those, you put your -2 of those, you put your -1 of those, and you realize that you have no remainder. So the answer is the quotient line. It's the 2x squared minus 3x plus 1. Okay.
Oh, because everything would be.
Yeah.
Oh,
Don't.
heck yeah.
I'm not making. Don't. You don't need to stop talking, and I'm not going to make fun of you. Yes, when you multiply everything by 1, that's why you get those dead carbon copies of white.
That's awesome.
Yeah. Right. One more, and then I'll let you work.
It's basically the same thing with the eight.
Totally. Yeah. By the way, if you're a flex pulled person, I got a really full flex today. So if we can use some of today's class time for me to give you some assistance, that would help a lot because flex is going to be pretty packed. So during class would be super awesome too.
You give us a little break here.
Where's the missing term, Sammy? In the divisor, right. So this time the missing term is in the divisor, not the dividend. So we're going to start with our long division sign.
Wait, I don't know.
So you got 3x squared
I don't know how
minus
to
1.
find this.
You got 3x squared minus 1.
This is like 3x squared plus 0x minus 1. You see how it's missing its x to the 1 term in the middle?
Yeah.
So the exponents jump from 2 to just 0, nothing. So what's missing is the term that should be there with the x to the 1. So what we need to think of it as is, let me show you out here. So it's really 3x squared plus 0x, because 0x is the same as there not being any x's. You need the term to physically be there so that the structure of the process that we're doing of the multiply by this, distribute to this, put it here, change this. If we don't fill in all the holes, then things aren't going to appear where we need them to appear.
So just put a 0 where there's this.
Yeah, like if you're missing your x squared, you put 0x squared. Whatever one you're missing, you fill with a 0 of those. Yeah. And then we're going to fill in the dividend, which is 3x to the 4th minus 6x to the 3rd plus 29 of those plus 1 of those minus 1. And we begin. Any questions so far? Yep. So that's it. Let's begin. What's going to go at the top of the very beginning of my quotient line? Yeah, all I need is x squared. Good job. And I'll make my parentheses blue again. So what you have to do every time you fill in part of the quotient line is you have to distribute through the blue parentheses. Yes, it would. And you'll see again, I hope it's 0x to the 3rd for the record. Yeah, so you'll see again why it's important that we have it there. So I hope. So as we distribute through the blue parentheses, what do we get first? Yeah, and switch it to negative 3x to the 4th. And then as I multiply, let me draw a red arrow for you. As I multiplied this by this, we all agree that we get 0, but it's x to the 3rd. And then you see why we had to have that there, because now the negative 6x to the third has a date to the prom. He's like, well, I need someone to add or subtract it. And we gave it that. Yes. Yeah, Kel.
Okay, so they're both positive. Wouldn't that mean it's a negative?
Yeah, and this goes back to Brandon's question. And I'm sorry that I just said a very bad example. You know, with zeros, it doesn't matter, right? But you're right. I can do that for you. We'll make it as you're right. But it doesn't matter. Adding 0 and subtracting 0 accomplish the same thing. But you know, I appreciate what you said. Yeah.
You told me I can never get negative.
So the third multiplication is the x squared times the negative 1, which would be negative 1x squared, but I'm going to put plus 1x squared. Good? Are we okay to hear?
Yeah.
Okay. So we're going to cancel these out. How many x cubes do we have? Mhm. Good job. And we reset. So what's going to be next in the quotient line? Thank you, Sam. That's exactly what I'm looking for. Negative 2x. If you can't get that, you and I'm not going to make fun of you and chuckle and make little comments. I just want to talk to you and show you what I'm doing. Because if you don't understand where negative 2x came from, you're making this too hard. You're thinking maybe down the line. All I'm asking you to do is literally multiply something to make it into something else. That's it. Nothing else. And now you take the newest addition to the top line and you distribute it through the blue parentheses. And as you go, you change the signs. So that would be negative 6x to the third. We put plus 6x to the third. The next one, again, Cale called me on this, and that's fine. He probably should have. The net result of what I'm about to do is going to be 0. So you can put plus 0x squared minus 0x squared. In principle, it should be plus 0x squared. But again, it doesn't matter. Yeah. But it'll have no bearing either way. And then the next one would be plus 2x. We put minus 2x.
What?
And then we combine like terms, cancel those. How many x squareds?
30.
How many x's? Negative 1. And then you drop that minus 1 all the way down. And then it resets. What do we have to multiply 3x squared by to make it into 30x squared? Plus 10, Sage, good. So plus 10. And then we multiply and switch signs. Multiply through the blue parentheses. Get that. And the reason I wanted 2 examples today wasn't just so that we could have a hole in the dividend and a hole in the divisor, but also I wanted to make sure that we could look at the remainder, because I know that's something that's still vexing a couple of you. Yeah, Cale? Is 0x. I'm not making fun of you. I don't know why they are so entertained by your questions today. Does that make sense?
Yeah.
Okay. You sure? Okay. So now it's time to combine our like terms. And when we combine downwards, the x squareds go poof. How many x's we got?
1.
Negative x. When you add negative x and negative 0x, it just stays at negative x, and then you get plus 9. So I've gotten this, I don't know if it was a direct question or people just saying this is what I suck at. How we write this now is quotient plus remainder over divisor. I'm sure that's in your notes at least twice by now. That's up to you. I'm going to do it by the book, and then we'll talk about that if you want. This will always work every time. Oh, no. Great. Excellent question. No, you don't need to. When we write the answer now, you can leave it out. Totally. Yep. The 0 is there just so, Colby, just so we could do the problem. But great question. So when we go to write this out, we're going to start by writing the quotient. And then just to be robotic about it, I'm just going to put a plus sign. And then I'm going to draw a little fraction here, like this. And what's my remainder? Negative x plus 9. All over. Yep. And if you didn't hear Colby's question, it's a dandy. You don't need the zeros when you rewrite your answer. They're only there to make the problem mechanically workable as we went. Do you have any questions?
What if we do the answer?
Then that's fine. That's your choice. No harm, no foul. Brandon, this would be a good time to not put a minus right here, because then you'd have to have your top, if you just, in case you're interested, you'd have to really watch out here. So if you did put a negative here, like a minus, then your fraction would be x minus 9 over 3x squared minus 1. Do you see how I had to change the signs of both of the things on top?
Oh, yeah.
As a general practice, Winslow, I think I would just put a plus here. It's easier. Then you just copy it in. Okay. All right, so you guys have some problems. They're hand selected in Delta Math. They're all yours.